Hello, stat students. Last time we talked about quantitative data and how to find the measure of central tendency and spread and how to interpret those. Today, we're going to talk about how to display quantitative data, and we're going to display it in dot plots, stem plots, histograms, and box plots. Let's start with the most basic one. For a dot plot, you make a number line, you plot the correct number of dots above the value, you analyze the distribution. It's best used for small to medium sets of data. Here's the data regarding the number of family members for 10 randomly selected U.S. residents from the 2000 census. Construct a dot plot of the data. So this data set is very small, and the biggest number is 6. So I'm just going to number from 0 to, at least 6. Then label the horizontal axis, number of family members. Because you always want to label your graphs. And then I'm going to start plotting. So we have a dot above the 2. Try and make the dots the same size. 1 above the 6. 1 above the 2 again. 1 above the 4. 2 3s. 2 4s. A 1. And a 4. We'll talk about the analyzing part later. Next one is a stem plot. This is best used for small to medium sets of data. Each value is separated into stem, which is all the digits, but the last one, and a leaf, which is the last digit. You write stems in a vertical column with the smallest at the top, and then once you do that, you draw a bar, a vertical line to the right of the column. You do not skip any stems, even if there's no data value for that particular stem. Write each leaf in the row to the right of the stem in increasing order. Out to the right, provide a key that explains how to read what each value represents. Going back to a sample we've already done, which gender is taller, males or females? So you have male and female heights from 14-year-olds from the UK in centimeters. And we're just going to draw, or the dot plot, the stem plot is already made for the male heights. Let's label it. Now, how do we read it? So here's our stems. The smallest is in the 150s. The largest height is in the 180s. So you'd read it 151, 154, 157, and so on. And notice the stems are listed in order. And if there was something, say there was nothing in the 190s, you would put a 19 there and then go to 20s and then put your 201 or whatever. And then lastly, the key 15 vertical bar 1 represents a male who is 151 centimeters tall. That's it for a stem plot for a basic one. So now we're going to talk about special cases. The first one is a splitting stem. If you have less than 5 stems, like our stem plot above, or if one or more stem has 5 or more leaves, so like the 16 stem had 6 leaves, this would be a good way to draw your stem plot, so splitting them. The stem is used twice, so if you look, notice 15 is used twice, 16 is used twice. The first one will have leaves 0 through 4, and the second one will have leaves 5 through 9. So what do you mean 0 through 4? Or what do I mean? So it'd be 150 to 154 goes in the first row, 155 to 159 goes in the second row, 160 to 164, and so on. These are male heights. And notice the key is made again. It just shows more of a spread instead of numbers all bunched together. So sometimes this is really useful, and then you can describe this distribution. The other special case is a back-to-back stem plots. This allows you to break apart your data into two categories, like in our example, male and female heights, and graph one category on one side of the stem and the other category on the other side of the stem. This allows you to compare the distribution for the two categories. So here are male and female heights in a back-to-back stem plot, and you can just title it male and female heights. There's a key already there. We already know how to read the right side. How do you read the left side? So let's just take 16 as our stem, for example. So you would read that first height as 165, then 165, 166, and so on. And also, I did forget to mention, this is a back-to-back stem plot, and it is a split stem as well, because there are two leaves for each one. Or I'm sorry, two stems, my bad, for each one. And so this shows the distribution of females more clumped together, whereas um, the male ones are more spread out. We'll talk about the how to describe the distribution next. So how do we examine a distribution? We are basically asked to describe it. And when you're describing any distribution, you want to use the acronym SOX, plus I always throw in context. So on an exam, it'll just tell you in context, tell what it means. So according to the problem. So the first one, shape, it can be unimodal with one peak. So I'm going to draw it. It's not that greatest. It can be skewed right. So the peak is to the left and you have a long tail. So that is skewed right. I'll put SR for abbreviation's sake. Skewed left, where the peak is to your right and your tail is to the left. Okay. It can be bimodal. Looks something like this. It could be multimodal, have many modes, or it could be uniform, pretty much where it's pretty flat. It doesn't have to be a straight line, but all values are roughly the same. So, as far as the center goes, remember we can use mean, median, or mode. If we use the mode, we're going to look at the peak. If we are going to use the median, 50% of the values are going to be above and approximately 50 below. So we're going to look at the midpoint for a median. And mode is a peak. And mean is going to be your average or balancing point. For spread, if we're going to use the mode, we want to use the range, which is the highest minus the lowest. So I'll put down, goes hand in hand with mode. The interquartile range goes hand in hand with median, and the standard deviation goes hand in hand with mean. These three measures of spread are known as variability. That leads us to our first example on describing distributions. Brian and Jessica have decided to move and are considering 7 different cities. The dot plots for 4 cities show the daily high temperatures for June, July, and August for each of these cities. Quickly describe each distribution. I don't know how quickly we're going to describe it. We'll do our best. So we want to make sure we use SOX. So shape, outlier, center, spread, whatever order, it doesn't matter. We don't really know individual exact values. So most of the time when we don't know that, we're going to use our mode for center. So use mode for center since we don't know individual values. And we'll use the range for spread then. We'll use range. When we can, we'll use something else. So the first thing that we should do is draw a density curve above the graph. So this one looks pretty uniform. So the best description of this particular graph is it's uniform. And since it's uniform, it's really not the best thing to pick mode as the center. So let's use median. The median, so find where you think is approximately the middle. And I think based on these other graphs too, but based on this graph, you can't really look at the other graphs. I think the median is right around 80-ish, right around there. So that takes care of shape and center. As far as spread goes, the range would be this number here. So 106 minus 60. That would be 46. And finally, there are no apparent outliers. Okay. Now, I didn't say for whether it's the range is 46 degrees Celsius or Fahrenheit. We don't really know, so I didn't really add the context portion of it. Let's look at plot E. Oops, I guess I could have done a better job drawing it, but looks pretty symmetrical. I just didn't do a very good job drawing it, but it is pretty symmetrical because I missed this little portion. I think I should erase that. There we go. So maybe I'll do a better job this time. There, that's a little bit better. So this particular one is symmetric. The mode is around 80. The range, same as the previous one, 46. But there's two possible outliers. Without knowing the exact values, we can't calculate it, so it's best to use the word possible instead of saying there are two outliers. One at 60 and the other at 106. And there's that one. Okay, for the next one, definite tail to the right. Should probably not use yellow, but I won't use it then, just so you guys can see better. So right skewed. The mode is right here, so 78. The range, you have 100 here, 76 here. So range is 24. And then lastly, no outliers. Okay, and our final, let's use this color just because I want to. So our last graph, okay, it's definitely left skewed because the tail is on the left. Okay, so left skewed. Mode is, let's see, 85, 58, so 27. Or, I'm sorry, the mode is the peak, so it'd be 84. The range is 27. And there are no outliers. No possible outliers anyway. Okay, so there are the distributions. I did it pretty quickly. Hopefully that makes sense. You'll be able to do that on your homework. Okay, our next way of displaying data is via histograms. Let me change back my color. Oops. Histograms are best suited for large sets of data and data that does not have repeated values. Each histograms take values and places them in bins, which is an interval of values. Each bar represents the number of values. In that interval or bin. All intervals or bins should be equal in width. The lower boundary for the bin is always included in the interval, but the second boundary is not included, and I'll mention that when we do our example. It will be beginning for the next bin. Here's our sample problem. Here are data for the amount of fat in grams for McDonald's beef sandwiches. And so you have the sandwiches and the number of fat grams listed. I do want to mention one more thing before we do this example. And you can choose to write this or not, but it is very key to remember, and students do often get them mixed up. Histograms do not have spaces between the bars. Bar graphs do. Right. So we are asked to create a histogram with bin widths of 5, and then we're asked to describe the distribution. So the first thing we should do is label our graph. So McDonald's beef sandwiches. Our horizontal axis will be fat calories, grams, and our vertical axis will be our frequency. There we go. And then our fat calorie grams are anywhere from 9 to 42. So what we could do is we can subtract 42 minus 9, which is 33, and then divide by how many of these there are, or you can try and make it fit starting at 0, totally up to you. I started this at 5 just because I wanted to. But I did have to make it the bin width of 5, so that I had to follow. That's what it said to do. But if we would have started at 0, we would have ended it right there at the very end, which would have worked as well. And then, honestly, you don't have anything appear more than 3 times, so depends on how you wanna make this. You can go from 0 all the way up to 4, or you could just go 0 to 10 since you have enough spaces. So let's see. So 2, 4, 6, 8, 10. And now we can go ahead and draw our bars. So we have one sandwich, a hamburger, that is between 5 and 10 grams of fat. Oops. Okay, for the next one, for 10 to 15, we also have only one sandwich. It's a cheeseburger. From 15 to 20, we have 3. From 20 to 25, let's see, if we look at our table, we have a double cheeseburger and a big and tasty, so 2. For 25 to 30, we have 4. For 30 to 35, we have none because the next biggest is 39, and we have 2 of those. And then lastly, we have 2 sandwiches with 40 to 45 fat grams. And that's how we draw a histogram. Now that we've drawn it, we can describe the distribution. So as far as the shape goes, again, it helps to draw that density curve. Looks pretty uniform, or I'm sorry, it looks pretty symmetric to me. Some of you might see it as skewed a little bit, depending on how you drew it, but I think it looks pretty symmetric. For the center, for this particular one, you could use the median, that the median is in the interval 25 to 30. So you're saying the median. Of course, you can go over here to your table and actually find the median. 6, 7. So I'm looking over here, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 1, 2, 3, 4, 5, 6, 7. This would be your median. So the median is 26. You can also say the median interval of 25 to 30. If you didn't know the exact values, you would use this as your median interval. If you had said mode, you could have said the mode was 19. If you had said this, so here we go. The spread, if you use the mode, in this case, it might have been easier. It would be easier to use the mode, but not necessarily. So the range is 42 minus 9, so 33. But you can easily find the IQR, and I'm going to go ahead and do it. And that's if you use the median. So let's see, 3. Here's Q1. Here's Q3. Or I'm sorry, Q3, Q1, because it's going in descending order. So we have 39 minus 19, so the IQR is 20. And I honestly would use these two. Okay, and then lastly, outliers. No outliers. And that's how you make a histogram. Okay, last but not least, we are going to do a box plot. So we're interested in a modified box plot. A modified box plot gives an outlier as well. A box plot is a graphical representation of the 5-number summary that we talked about previously. A modified box plot would also show if and where there are outliers. So since we're only interested in the 5-number summary, we're interested in these last 5 columns. And we're not interested in the sample size or the average or the standard deviation. We have this big little graph and we need to figure out how to scale it. So what I did was I took the largest for males, and which was 290, subtracted the smallest, and that was 263. Then I divided 263 by 21. And I got about like 13 something. So I decided, hey, you know what? I'm just going to scale by 15s, and I'm going to start somewhere so I can fit on the graph. Well, I could have started at 25, but I started a really nice, easier number. So I started at 20. And I counted that there were 21 of these lines. So labeling quickly, I'm going to say, so 20, I'm going to skip so it's not bunched up together. 50, 80, 110, 140, 170, 200, 230, 260, 290, and so on. And then we can go ahead and do our males. So plot starting with the smallest. The smallest is 27. So put it on here. and then draw a line at Q1, median, and Q3. So the median is 64.5. So let's say right here. I mean, you could put the dot first and then draw a line through it. That all helps also. 109.5, I do either. And then 167.5. 290 is our max. That's easy to plot. Okay, the box goes around Q1, median, and Q3. And the whiskers, these are known as whiskers, connect the maximum to Q3 and the minimum to Q1. And that's for males. Let's label it. Okay, let's go ahead and do our females. Okay, for a female, the smallest is 22. Q1 is 83. Median is 129. Q3 is 180. And I'll go ahead and draw the lines now. For me, it makes it easier to just draw the dots first. And then the maximum is 218. So I want to say right around here. Draw the box. Draw the whiskers. Oops. Trying to do too much there. Label. And there is your box plot. I want to draw your attention to the fact that, remember, each of these represents a quarter, approximately a quarter of the data. These represent the tails. So, we'll talk about when we talk about the distribution. So now let's talk about the distribution for males. It's right skewed. Often helps on your graph to label or draw or write the word tail, sorry. Since it's right skewed or left skewed, whatever, you want to use the median for your center, and then you can just find the information in your table right here. So center median is 109.5. The IQR, and again, you can just use the values from your table. 167.5 minus 64.5 is 103. And lastly, there are no outliers. Actually, we are supposed to figure this out, so I can't just tell you there are no outliers. So let's go ahead over here out to the side. I'm going to do the outliers for males. So you take, for our lower bound, you take Q1, which is 64.5, minus 1.5 times your IQR. So I did 1.5 times 103, and I got negative 90. And there are no values that are even negative. Then I did the upper bound, so Q3, so 167.5 plus the 1.5 times 103 IQR, and that gave me 322. Again, there's no number bigger than that. The biggest one was 290. So no outliers for the males. For the female, for Q1 is 83 minus 1.5 times, well, I guess we can go ahead and describe or finish talking about the males before we even do the females. So there are no outliers. If you look at the females, it's not symmetric. It could be pretty close. There's just a little bit of skew over there on the left. So I'm going to call this a tail. It's a slight skewness, but there's a skewness. So left skewed, center median, and again, look at the table, is 129. The IQR is 180 minus 83, so 97. Mm. And now let's determine if there are outliers. So 83 minus 1.5 times 97, and that gives us some negative number. So we don't even really care, but it's going to be negative. And so there are no negative values. And then for the upper bound outlier, you take Q3, which is 180, plus 1.5 times 97, and that gives us like 325 or something. And there's no number larger than 218, so no outliers. There's one thing I forgot, and I was about to end here, but I did not label my box plot. So this is the number of phone contacts. And that is it for today. Have a great day, stat students.